Click the bell icon to get latest videos from Ekeeda.
Hello friends, welcome back to the subject of Machine Design 1. We are right now learning about keys and their design aspects. In the previous session we have looked at different formulae and their failure modes. In today's session we are going to look at the design of a square sun key. So let us begin with the numerical. So friends, problem statement you can see at the screen. It says that select a standard square key to mount a gear on shaft diameter 25 mm. The power is to be transmitted is 15 kilowatt. The rotational speed given is 720 rpm. The material is already specified for us and whose value is given, and factor of safety is to be maintained is equal to 3. So let us begin with it. So this is what the diameter of shaft, so let us mention it. Therefore small d comes out to be 25 mm. As we all know that a square sun key looks like this, where h and b are equal, and ISO standard wise they should be fourth part of the diameter, and length should be this much. So this is how the description of the important part is given. So let us move ahead for the design. We have been given the yield strength 460 Newton per millimeter square, and so that we can consider the tensile stress, the allowable value of tensile stress. Now for the ductile material, which is the given material, the compression and tension, they almost act similarly, and that's why their values are same. So let us say they are equal, and hence the value will come out to be the ratio of the yield strength with the factor of safety. If I sum up the value, I'll get the value somewhere around 153.33 Newton per millimeter square. I also know that shear stress for the ductile material has a standard relationship with tensile stress. If I apply that relation, I get the value 153.33 divided by 2. So value comes out to be 76.67 Newton per millimeter square. So these are what the important material properties that we have. Let's move ahead for the power calculation. We have been given 15 kilonewton, 15 kilowatt power transmitted at the designated RPM of 720. So the value of the torque that was to be transmitted comes out to be Newton millimeter. So that is what the value of torque that we get. So this is what the torque we need to consider for the design of the key. The next thing is, like, we'll go for the Aia standard, and the value of breadth or height should be at least 4 times this. So it comes out to be somewhere around 6.33 millimeter. So let us say precisely 6 millimeter. As it is directly proportional, we'll keep it the same. Now the value of shear stress is given by this particular formula, and therefore this is what the only dimension we need to figure out. So L will be given by 2 times the torque to be transmitted divided by dB, and allowable torque. Same thing for the compressive stress. I can say the length will be given by 4 times MT divided by dH into allowable compressive stress. The value of course is equal to the value that we need to transmit is divided by the value of D is 6, the value of B is also 6, into the allowable value of tau that we have found out is 76.67, and as we solve this example we get the value of L in millimeter. The same thing we can repeat over here for this consideration. Now try to understand, we are doing it in 2 ways, by means of shear stress and by means of compressive. Either way, if they are same, it's going to be the answer. If that is different, we'll go for the maximum length. So it comes out to be divided by 6 into 25. Let me make a correction here. Diameter is 25 and not 26. Into the value of shear that we already have, sorry, the value of compressive stress, that is, and therefore the length will have another answer. The value comes out to be 34.6 millimeter for both of them. So that is where we have found out the length. We have already found out the breadth and height of this particular key. So for the final selection of the key, it is designated by breadth into height into its length, and therefore selected key is 6 mm by 6 mm by 34 or 35 mm, which is our final selection for the given application. So that's where we end with the design of square Sankey. In the next section, we'll look at some formulae of design of square Sankey, and then we'll go for the numerical based on it. Thank you so much for watching this video. If you like this video, please subscribe to Ekeeda. Thank you.